Good morning, everybody, and welcome to today's webcast. We're excited to have you here today to learn about the Aerospike version 4.5 release. We put out a press release and wrote a blog and made it public that we now support Intel persistent memory. We're excited about that news and wanted to share the details with you today and give you the opportunity to ask questions. You'll note that we have a couple of distinguished guests here who will be doing the bulk of the presentation and answering your questions. I will introduce them in just a few minutes. But first, a couple of housekeeping points I want to make. We will be recording this call. And in case you would like to have access to that recording, we will make it available to you after today's session. So keep an eye out for an email from us with details on how to get the recording, and you're welcome to listen to this again, or if you'd like to share it with others within your organization, you are free field to do so. We will also make the slides available to you today, and look for that as well in a follow-on email. So I know those questions come up often when we have these types of events. So welcome to today's call. We'll quickly go through the agenda and then get on with the speakers. I am Bill O'Dell, and I run marketing here at Aerospike, and I will be the moderator today. So I will turn the remarks over to Brian and Alper as we go through today's events, and I'll go ahead and handle Q&A as they come in. You will notice you have a place in the console to ask questions. Go ahead and do those as they come up. I will look at those as they come in, and when we get to that part of the section, I will go ahead and tee the questions up to the appropriate speaker. So today, Brian is going to start us off with just giving an overview of what is Aerospike version 4.5, what do you need to know, what's different about that, how to start thinking about that within your respective companies. I will turn it over then to Alper at Intel, who will talk about Intel Optane DC persistent memory. A lot of great content here. This is a very strategic announcement for all of us and for Intel, and we want to make sure you get the opportunity to hear directly from Alper about what they're doing there. And then we'll turn it over to Brian and Alper to answer some questions, and also just make sure you understand how to think about this for your Aerospike environment going forward, okay? And then we'll do some Q&A. So with that, let me give a brief overview of today's speaker. We're delighted to have Alper Ilkbahar here with us from Intel. Alper is the Vice President in the Data Center Group and General Manager of the Data Center Memory and Storage Solutions organization at Intel. In that role, he oversees the development and enablement of memory and storage solutions by integrating innovative hardware and software for next-generation data centers. Alper is a veteran in the semiconductor and storage industry. He rejoined Intel in 2016 from SanDisk, which acquired Western Digital, and most recently at SanDisk, he was the Vice President and GM of Storage Class Memory Solutions, a business unit dedicated to non-volatile, high-performance memory technology. So he knows a little bit about memory and storage, and he will be a terrific presenter for all of you to hear from and to ask questions. I would like to also point out that Alper is distinguished more so than his background. He also holds more than 50 patents in the field of semiconductor process, device design, and testing. So we're very, very delighted to have Alper make the time today to share his thoughts on what Intel is doing with persistent memory. Brian Bulkowski, some of you know, since this is an Aerospike customer event, many of you have met Brian over the years. He is a founder of Aerospike. He's also the CTO of Aerospike. Brian has almost 30 years in Silicon Valley. His motivations for starting the company was sort of the confluence of what he saw as the rapidly advancing flash storage technology with lower costs that weren't being fully utilized by database systems at the time, and that had some scaling limitations. And he saw the need to do something disruptive in the database industry, which we all feel we have done here at Aerospike. So we're delighted to have Brian here. He also has a deep technical background, having been a lead engineer at Novell and chief architecture for cable solutions at Liberate. So excited to have Brian here as well to share his thoughts as the founder of the business. So with that, I'm going to turn it over to Brian, who's going to talk a little bit about what's the news and how to think about that for you and your respective companies. So Brian, over to you. Good morning, good afternoon. Thank you for joining us here at Aerospike and Intel for this roundup of what Aerospike 4.5, the first persistent memory optimized database, could offer you. You know that we love all of you customers and folks who use Aerospike. We slave every day to make sure that we're using the best of hardware, presenting great hardware optimizations. And we have worked with Intel over the years to provide some really exciting specific optimizations for this technology. Now, Alper is going to talk to you about these specific technologies, so I'll leave that to him. The Aerospike 4.5 release really focuses on the specific memory optimizations that make Optane DC persistent memory shine. And as you know, we've been involved also with the Optane storage subsystems, what I call Optane NVMe in shorthand, and have presented to you all the benefits of that. This is a slightly different device. This is putting the Optane memory chips on the memory bus. Aerospike's specific optimizations for this have focused primarily around using that store as a persistent store, which gives you higher levels of availability, fewer index rebuilds across, and no index rebuilds across reboots. And when we did that, we found that we could push now machines to much higher levels of transactions per second. Now, I can't tell you the specifics of the numbers. We're still working through NDA issues with some of the players, but what we do know is that there is a really minimal performance change when using hybrid memory solutions, which is to say data in NAND as well as indexes in persistent memory. So even though we also believe in, with our tiered architecture, placing all information in persistent memory, the fact that we can get multi-million transactions per second with this kind of design is super exciting. And we'll go into that a little bit later in detail. But the point here is Aerospike 4.5 is here. And we're able to take advantage of it. We released this as available technology. Now, just as a quick overview of that, remember that Aerospike has a tiered architecture for the different implementation strategies. I find that most of our prior deployments did include some pure in memory, where, you know, all DRAM does have some performance benefits, some hybrid memory, and that's where we're using NAND, often NVMe, for bulk storage, but indexes in DRAM, and the recent Aerospike 4.3 release of all flash, which allows even lower RAM reduction. So with all of these different capabilities, Aerospike as a feature-rich database gives you a lot of different performance characteristics, a lot of different places that you can deploy them in your organization. So that is really the springboard for us to be able to then take a really hard look at what we could do with persistent memory. And so let me hand it off to Alper here to discuss, allow him to talk about how the Intel technology can benefit you.
Thank you, Brian. Good morning, everyone. Good morning from Intel. Good morning from California to you all. And thank you for being part of this conversation today. We're really excited about our new technology, which we call the Intel Optane Data Center Persistent Memory. And we're very excited about having Aerospike as a strong partner in participating in the innovation and making most advantage out of this totally new technology with us. So let's just jump into the next slide, please. We all talk about the explosion of data. I mean, you all know that data is growing exponentially. We are generating data, and machines, things, everything is generating data. But more importantly, I think companies, businesses are looking into ways of extracting insights, value out of vast amounts of data. And so this is not just the data growing, but this also drives the need, especially combined with the need to get real-time insights and also using new analytics tools such as machine learning and deep learning type of tools. Not just are we looking at a lot more data, but we're also heating up the data. What I mean by that is that we're actually doing analysis on more and more data. The data set that's being used actively, so the warm data is growing significantly. So this drives the need to move data closer to the CPU, otherwise being far away, sitting somewhere on your storage. It's going to be really not performant. You're not going to be able to do real-time analysis on vast amounts of data. And that's essentially where we've had this limitation on existing technologies, because typically when we think about data being close to the CPU, and if you would please go to the next slide. Thank you. If you think about that, we always thought about memory or DRAM as being the only vehicle for putting hot data close to the CPU, and everything else below that used to be just storage. And when you compare memory versus storage latencies, even the fastest storage arrays or storage, direct attached storage with the fastest NVMe drives, it's 3 orders of magnitude, 1,000 times longer latencies at best, and which wasn't very inducive of getting in-memory type of analytics on very large data sets. So with the Intel persistent memory, actually we are not only introducing a new product, but we're creating a totally new product category and re-architecting the memory and storage hierarchy. So this is the persistent memory hierarchy, where we are introducing the Intel Optane DC persistent memory product, delivering capacity, performance, and availability into the applications. So I'll touch on that product and some of the features on the next slide, please. So the Optane DC persistent memory product essentially delivers big and affordable memory. So the product actually, as you can see here, is in a DIMM form factor that is pin compatible with the DDR4 DDR4 bus, attaches into this DDR bus directly to the CPU, and it comes in 128, 256, and 512 gigabyte modules. So compare that to your typical 32 gigabyte type of DRAM DIMMs, or maybe the new ones that are going to come out next year are going to be 64. So you can already see that we are offering vastly greater capacities compared to existing DRAM technologies. Just like DRAM, this technology allows you direct load store accesses into the media, and you can do byte addressability through it. And of course, being a non-volatile memory technology, the memory technology here that we're showing is a persistent technology, so you can remove the power to it and you will retain the data. So this allows you to really achieve high performance storage through native persistence, and to support that we have enabled hardware encryption and high reliability features on this product. So it is a totally new category of product, achieving DRAM-like performance for storage that was never possible before, and byte addressability and direct load store access without any involvement of software accessing your storage tier. So we're really excited about all the possibilities that are going to be enabled through this innovation. So in the next slide, we will talk about the different modes of operation that we are enabling on the Optane DC persistent memory product. The first mode that we're going to talk about is what we call the AppDirect mode. In the AppDirect mode, the software, the platform, the applications are aware of 2 distinct types of memory resources on the platform: the traditional DRAM as well as the persistent memory. And the applications and the software stack will make the determination where to put which type of data structure, so that it can optimize persistence, it can optimize performance, and get the most out of the technology. And actually, Aerospike 4.5 has done very much this, and Brian talked about how they have achieved this, and that he's going to get into some more details later. But as you can imagine, this type of an optimization requires revisiting the applications you had, or at least the data access layer of the applications. So we have created a really vibrant ecosystem of applications, the fundamental operating systems, virtualization layers. So all of this is now happening as we're moving into the launch of this product. But we also wanted to make sure that legacy applications can take advantage of this really affordable, large capacity memory technology that we're bringing to the market. And to enable that, we came up with this new mode that we call the memory mode. In the memory mode, our Xeon CPU, and this is going to start happening with the upcoming Cascade Lake Xeon scalable processor. The memory controller that sits on our Xeon processor essentially will treat the pool of the memory, which is the DRAM as well as the persistent memory, as one uniform memory pool, and it manages the DRAM in the system as a last level of cache that sits in front of the persistent memory. When you do that, the applications essentially see one contiguous memory space. The whole operation of the management of the cache is transparent to the application and is managed by the processor without the software's involvement. So this mode essentially is pretty unique in that it enables legacy applications without any modifications to use this technology, this product. Going to the next slide, I want to quickly touch on really what it took for us to make this technology work, because it's not just a memory technology, it's not a semiconductor innovation only, although it's pretty amazing what's happening at that low-level device physics. It's really phenomenal. That excites me a lot, but most of the work that we've been doing over the past few years has really gone into figuring out how do we make this innovation, how to work through the system-level integration. How do we enable the Intel Xeon scalable processor, re-architecting this, the processor architecture around this memory, enabling it? How do we integrate this into the platform, enabling the BIOS changes, UEFI changes, all the operating systems and the software that goes around that. So there has been an immense amount of work that we and our partners have put in to make this technology work, and it's been all worthwhile because the results are pretty phenomenal. And I'll share with you some of the latest results that we've been seeing in some of the workloads that we've been running. So if you would please jump into the next slide. I want to touch on very few of the examples that we've been talking about from different applications in our ecosystem. One of them in the large data analytics space, in-memory analytics space, Spark from Databricks, pretty popular. We were able to show with our technology that when you use enough memory and able to fit your entire data set into the memory where previously it was spilling into disk, we are seeing speed ups of up to 8x, 800% when you use the Intel Optane DC persistent memory technology. Another great advantage that we're bringing to the table here is using the persistence feature that was never possible before in the memory. So in memory structures, when you restart a database, your restart times go from minutes and hours to seconds. And this is an example that we have highlighted with actually the Aerospike team as well, that our restart times literally improved over 100 times. And when you have that kind of a capability, your availability goes from 3 nines to 5 nines kind of a space. And that's really critical for mission-critical systems, people who are relying on their systems to be up and running 24/7. really valued this kind of a capability. And another example that we talked about was essentially this is a non-volatile technology, so you could use it as a storage. But unlike other storage elements, replication, which is very important in storage subsystems, can be performed over RDMA without the involvement of software and the CPU. And we've demonstrated 14x improvements in replication speed and latency improvements because you're driving everything through the hardware directly. And these are phenomenal improvements that we have been able to show. So we are very excited about the technology. We're very excited about having Aerospike with us as one of the pioneers taking advantage of this new technology. So with that, I'd like to go back to our Aerospike friends and continue the presentation, please.
Thank you, Alper, for that quick overview of the unbelievable investment that Intel has made in really rethinking the storage architecture. I thought that was a terrific oversight. I want to just remind the audience, because we have quite a few people who are on the call and the webcast, that you can submit questions. And so as you are listening to Alper and Brian, who I'll turn over, just think about those questions. Look to your console on the right-hand side, and it will be a place where you can submit your questions. So that's a gentle nudge for me to go ahead and start teeing those up. So thank you, Alper. I'm going to go ahead and turn it back over to Brian for some additional information on how to think about all of this in the context of Aerospike. So Brian, back to you.
Thanks, Bill. And I would recommend submitting some questions. Alper is one of the luminaries of Intel. Persistent memory and Optane has been called Alper's baby within Intel, and it's a unique opportunity to ask him some questions. So this is partially a call to action for you all as our customers to really start considering architecturally what persistent memory and persistent memory could mean to to what you do. And so let me break it down super simple and super straightforward, okay? This is about two things. It's about scale and it's about reliability. So you could look at adding persistent memory nodes to your clusters, or a new cluster with persistent memory and NAND nodes, and you're going to get two things out of it. You will get practical petabyte scale deployments, and what that means is we were limited previously to DRAM, and I'm going to say practically, right? There's some esoteric hardware out there, but practically there has been a limit of about 1 terabyte per node, and that has a bunch of issues, right? That ends up limiting scale in an Aerospike deployment for some of you out there. Now, although we've implemented all flash and putting those indexes on NAND, there are performance implications of that. NAND, as Alper said, is 3 orders of magnitude slower. And I have a recent blog post about what an order of magnitude is and how really, really big 3 orders of magnitude is. That's a topic for another day. But what this means is you're going to be able to take those 1 terabyte machines and roll them up as 6 terabyte indexed machines. So if you have been hitting those kinds of scale boundaries on your bare metal deployments and saying, hey, you know, geez, this is going to be a 50 node cluster, a 100 node cluster, a 150 node cluster, and suddenly you're going to see cluster sizes shrink quite potentially. And that's going to save you a lot of money. Now, we're not sure, and this is a great question for Alper, but I know Intel's position on this, what the timeline and price is, but let's just say that our call to action here is, if this sounds intriguing, if you have a use case that is petabyte plus scale, and you'd like to talk to Aerospike and Intel about how to roll out much, much higher scale than you've seen before, please give us a call. We're here and interested. Intel is interested. We're trying to make some connections about who could do this and who is going to be excited about it. So larger data sets at a lower cost. Now, second of all, higher availability. You heard Alper say it as well. What this means is, even with Aerospike's fast restart, if you go all the way cold, you have a persistent data store. What this means is you will be able to take machines all the way down and bring them all the way back up, and go through the sub-second, this is what we demonstrated at an Intel event, sub-second rebuild of your indexes. You're not rebuilding them. You're just validating them and checking them, and you're not having to scan through all of that slower storage in order to do so. So those are two key benefits. Bigger clusters, more data. Alper said it, everyone agrees, data is growing. So what I'm challenging you, we here are challenging you, is we believe that there are likely larger use cases you may not have considered where you still need hundreds of thousands of transactions, millions of transactions per second, tens of millions, 50s of millions, hundreds of millions, and on much larger data sets, well above 100 terabytes, where persistent memory could be an absolute killer technology. So that's what we're here to say. Now, where could we use any of that stuff? Among our customer base, you guys, I like to get out and talk to you. Who are the largest consumers of data today? It's certainly fraud detection. Those of you who are out there in the fraud detection universe who are on this call certainly know that using 100 terabytes on the front edge is absolutely reasonable. We have folks who are doing essentially simulation-style workloads who don't just have today's, the up-to-the-moment 100 terabytes. They also have a simulation store that wants to have 10s to 20s times that on the back side and still run your simulations quickly and accurately. And as I like to say, anytime there's money, there's fraud. So for those of you, let's say in real-time gaming, if you are you've got your anti-fraud systems, right? You don't want to have bots destroying your game and gameplay. And so maybe you can take a page from some of the folks using Aerospike in financial service and transactions to start looking at the kind of combinations that machine learning plus traditional algorithms can use and bring those 100 of terabyte style systems, because we can do so quickly, accurately with low cluster counts, and we've done it for a variety of customers. In particular, let me bring out another case. We've currently been working with some multi-billion-dollar retailers regarding essentially what's called here recommending and targeting engines. And I'm going to fill in there and also to say that's our ad tech guys. So this is the essential use case, a common use case of Aerospike, which is you have a individual user. That individual user has a whole bunch of actions. Think about it as Internet of People, where you have an individual sensor, an individual person, all the things that they've done recently. You may have, let's say, a cold store or a system of record in the center, which has a much larger set of data. Maybe it's used for some real-time research. Maybe it's the underlying store with edge caches linked with Aerospike XDR, say, where you have maybe smaller 10 terabyte edge systems, but then you need to have, or a new architecture desires having a core system of much higher scale. So persistent memory is a great case where you can get that level of scale in a central petabyte scale system at a reasonable price. So hopefully this is giving you some ideas of how you can fit this kind of scale into your architecture, the next level of innovation that your company may be able to achieve. And again, this is to help get you guys to call us up, which is to say us in Intel. Now let me talk about one extra thing. I've been mentioning bare metal, and I know a lot of you guys are in public clouds. So even though this is a technology that has been bare metal focused, because we're talking about the memory bus and we're talking about chassis and we're talking about this direct integration with the CPUs, the public cloud vendors are already all over this. Intel had me up at their cloud event, gosh, I don't know how long ago it was, a year and a half ago, and I predicted that the adoption of Optane technology in all of its forms would be supercharged by the fact that you could go through a POC cycle in public clouds. You weren't going to have to do what we've done for the last 20 years where, call up, Dell or HP or Supermicro or your friendly whoever, have them drop ship in a bunch of rack units and guys to wire it up, and then you've got to allocate 2 people to go and figure out the installation gotchas, yada, yada, yada. We weren't going to have to do that as an industry. Our relationship with Intel and engineering has been a case in point here, where with all of the hardware vendors, but also with Intel, we have logins and we have machines that they maintain. And I can't tell you how much it has made building software on this technology faster, more agile, and far more effective. I'm looking forward to you all being able to check out Optane in its various forms by working with your public cloud providers. Google in specific has already announced publicly the instance types that they have for Optane persistent memory. Aerospike has validated on top of those. Again, based on NDAs, we can't tell you about the exact sizes and shapes of all of these things, but let you know that we have done our tests on it. It does work, and we would look forward to different kinds of POCs available within that environment as well. So point here, higher scale, better availability, more reliability, what's not to like. We look forward to conversations in that.
Thanks, Brian. Also want to thank those of you that have submitted some questions. So we have a couple questions coming in. So I want to encourage you again to go ahead and do that. Just look to the console to the right, and you'll see a very simple button to give you instructions on how to submit some questions. We have a couple. So I'm going to start off with you, Alper. Not to pick on you, but this is probably a question you get asked a lot, and so I thought I would place it in front of you and you can answer it as you feel fit. But you mentioned Cascade Lake and some interoperability between Cascade Lake and Intel persistent memory that would be important for people to consider. There's a question here about any guidelines you can give people about the rollout timelines for Cascade Lake.
Yeah, I think I'm sure many of you are aware that the way Intel's product start shipments is that we start through an early ship cycle for our early customers, typically in the cloud, to start having a look at the technology, start early deployments, beta deployments, as well as our OEM partners to do early POC work and check out the beta versions of the hardware. So we started actually revenue shipments of the persistent memory last year, Q3 of last year. And as Brian mentioned, Google already has public instances available with Intel Optane persistent memory. So we would definitely encourage you to check that out, as well as talk to your favorite OEM partners, because they too are right now in evaluation and POC cycles with the technology. As far as the official launch of the Cascade Lake and the Optane persistent memory together, we are targeting definitely the first half of 2019. The exact timing probably is going to be late Q1, early Q2. We're narrowing it down, so we're a few months away from it. It's not a distant future at all. It's very near future, so we're within a few months of launching this and making it publicly generally available. But for all of you who are looking at this and thinking about this, there is multiple ways for you to play with it, kick the tires, if you will, and hopefully enjoy the benefits earlier than later.
Thanks, Alper. And I want to also just echo what Brian said a moment ago, which is if you would like to start testing it today with Aerospike 4.5, you can do that. You can contact us and we can get you access to 4.5. It's generally available. It's fully QA'd. And as Alper said, there's a number of OEM and cloud service providers that have them already. And you can reach out to your favorite one. In fact, if you look at the section of your console that says attachment and links, and this will come out in an email, you will see a link to a page about everything you need to know about Intel persistent memory, including all of the partners they have that you can reach out to get access or ask to get access to their beta programs so you can start testing. So we encourage you to go ahead and do that. Along those lines, Alper, I'll just continue with you for a second. There is a question here. I'm not so sure how you would answer it, but the question is probably one that you get hit with too, which is, given the difference in the kind of architecture as well as the cost structure for Intel Optane persistent memory, do you have any idea or advice for people in terms of how that might change the pricing structure with some of your cloud service providers. You may not know that yet, but I don't know if there's any comments you can make about that. I think people are just thinking that that might change, and I don't know if you can comment on that or provide any direction.
Right. I mean, obviously, I cannot quite comment on how the end customers are going to price this technology. That's something that they will have to advise and figure out. But certainly, when we come out with this technology, our intent is to make sure that we have removed the memory bottlenecks in a very cost-effective way and make it significantly easier and also more cost-effective to bring a lot more data closer to the CPU and enable all these kind of analytics and new real-time workloads that we need to run. So we definitely are trying to achieve cost savings over what would be DRAM. And of course, everything else we talked about, what's simply not possible today in terms of the scale, the persistence, and all of that are going to be great things that hopefully all of us will enjoy with this technology as well.
Thanks, Alper. Brian, I'm gonna pick on you a little bit. There's a question in here about going back to what Alper said about there's basically two modes that people can operate in, AppDirect or memory mode. And somebody asked the question that might be beneficial for others. Is there any particular advice we can give people? Is there anything we did to optimize using persistent memory in both of those modes?
Sure, Bill. I'd be happy to answer some of that. So this is a question that has come up as I've been giving talks around the industry about persistent memory, is how much programming was required to do the kind of optimizations that we did at Aerospike. Let me first say that, of course, we used AppDirect Mode, and so will every database company that has to do an optimization. Memory mode really makes it look entirely transparent, and this was Intel's quite correct capability of a zero code change for applications benefit. And so, I was in Costco yesterday, and I saw Optane shipping in every single little PC, and that's awesome. Obviously, those all apps didn't get rewritten. So we're in AppDirect mode. So is SAP with their database optimizations. And so if you want to start writing your own code to persistent memory, please look at, I think it's pmem.io. That's the website that has the libraries that we use. We came in at the lowest level of integration. We found that using some of the object stores, the higher level systems, that's not really us, but it will perhaps benefit people who are, just want a quick win with persistent memory. We found that the scale of Aerospike and speed of Aerospike, of course, we were going to integrate our object formats, our object stores, our search and index technologies directly into the lower levels of persistent memory. That also required us to think a little bit about how data is committed, how the integrity of data works. And really, the good news for us was that persistent memory optimizations fell out of our hybrid memory and tiered architecture. So the fact that we have different kinds of storage paths, we don't really think of them as storage, but access software modules for reading and writing indexes versus reading and writing individual data allowed us to do the specific optimizations going far beyond what's in AppDirect mode.
Terrific. I'll come back again, Brian. You mentioned earlier in your remarks that we can now, Aerospike can now scale to petabyte scale deployments, and you showed an image of a tiered storage architecture that I think might be new to some of the people on the call here today, Aerospike. Can you talk a little bit more? There's some questions coming in about what did you mean by that? Because I think that's unique to Aerospike relative to some of the other vendors in the market. So how do we actually help people scale to petabyte scale sort of deployments?
Sure. So there's, I would say, two different aspects to scaling to petabyte scale with Aerospike. And we long know that it is really a place where a database like HBase can shine, because the rotational disk optimizations, how they do clustering, stable clusters, thousands upon thousands of nodes. Or we find folks using or trying to use Cassandra at those levels of scale. And it can be done. However, with Aerospike, we've done a few recent innovations to allow us to get up to those levels, and we have more planned in our product roadmap. So one of the key innovations we shipped just in December, not 6 weeks ago, 4 weeks ago, is the capability to do in-database compression. We found that a lot of the uses of Aerospike focusing on petabyte scale were using our internal list and map data structures. That's kind of like a short-term time series, right? And so at these levels of scale, being able to do in-database compression becomes a huge win, can often drop the amount of NAND you need in the customer case we deployed with by a factor of 3. So that alone allowed us to use cloud instances that were only a few terabytes in raw storage to build up a cluster that was effective with petabyte sizes. So the fact that we have a lot of customers running in the 90, 100, 110 node size has certainly helped. Cluster stability, for those of you who are long-term customers, is way up after our 3.13 release. We now have entirely stable clusters at those sizes, and we're looking to push up to higher cluster sizes for individual clusters as well in the very near term. And feel free to reach out to either myself or your reps regarding capabilities in that direction on our product roadmap for that level of scale. Now, the final thing that's happened, of course, is NAND has gotten cheaper. So when we talk about scaling, you guys know that part of Aerospike's value proposition is leveraging NAND at a high performance levels. And so for bare metal installations, what that has meant is the fact that 6 terabyte drives in a 2.5-inch NVMe form factor are now common. Since Intel's on the line, we do very much like the Intel P4600 for that use case. It's an awesome drive. There's a few others out there, but Intel is shipping in high volumes in their 6 terabyte factor. That has allowed the onrush of 6 terabyte drives and chassis with 12 NVMe slots from Dell in a 2U factor. Just do the math. You're at very high levels of NAND. And if you happen to have a low DRAM or low latency solution, you don't even need persistent memory to get up into terabyte scale. There's the second factor, however, which is prices of NAND is dropping. If you look in the industry, there's a NAND glut. The fact that 3D NAND is now, and 3D processes are now widely available from multiple vendors, not just Samsung, which innovated in the space, but other folks are doing great work. That's part of what Intel shipped in their 4610s. So what that means is that not only are we getting high capacities, but the prices of NAND are dropping pretty severely for high performance stuff and also highly available for modest write load cases. So a combination of improved Aerospike technology and also higher cases of hardware performance are really pushing all that stuff. So if you're listening to this and you're thinking, geez, I didn't know I could get Aerospike that big, you know that's why we're here as your reps and your sales engineers. Call us in, say, hey, I heard Brian talk about petabyte scale Aerospike. I've got this use case. How could we size that out within my style of hardware deployment? Of course, we would be eager to help you out in that way, as would our hardware partners like Intel.
Terrific. I'm now going to pose questions to you both. So I'll suggest one of you first and the other one second. So, the kinds of applications and use cases that you both talked to sort of spoke to, at one level, this thing we can't stop reading about every day, which is edge computing. There's just millions of devices out there all over the world, massive amounts of data being created. The ingest of data is constant and continuous. And we've got these applications that are trying to make sense of these, of this data and figure out what to do. There's a lot of discussion around sort of real-time analytics and how do we drive, machine learning and AI-driven analytics that can help sort of inform applications at the edge. Aerospike, with the ad tech and the fraud detection that Brian talked about, has created a brand around that. We do that very, very well, and Intel knows that and so forth. But when we talk about persistent memory being a completely new storage, paradigm, Alper, I'll pose this question to you. The question comes up, well, so what was the trade-off between sort of the persistence element, the storage capacity, and performance? Because people understand sort of what traditional DRAM performance looks like, and I know you can't produce, specific numbers at this point in time. You'll save that for your launch in Q1 or Q2, nor can we. We've seen some very exciting things in our labs, but I just thought if you can give any sort of guidelines or comments about how should people be thinking about performance with Intel persistent memory, I think that would be helpful for people.
Sure, Bill. As you suggested, there are a lot of optimizations and trade-offs that you can do with any technology, memory media technologies around performance versus cost versus density. So you have to hit the right trade-offs. Our approach actually is thinking about the problems not as an element of the component performance necessarily, but think about what are all the things that you do at a system level, at a full solution level, so that your applications, your workloads performance is not compromised. And that's the point of focus that we have. And when you think and approach problems like that, your degrees of freedom actually multiply. And this is sort of what we touched upon earlier by, for example, the AppDirect Mode that we talked about, how the software's ability to place the right data structures into the right resources plays a significant role in getting the right performance out of the system. The persistent memory, although orders of magnitude faster than NAND, is still slower than DRAM. But when you use it in the right way, if your data structures are placed correctly, the performance difference between a DRAM only or a hybrid memory system that has DRAM and persistent memory together become indistinguishable almost. And this is sort of what Aerospike has achieved as well. So really, that's how I like to think about the problems we're looking at. And when you approach it from that angle and do your optimizations at a system and solution level, I think you really get to enjoy the persistence as well as the large capacity at a much lower cost without making too many compromises at performance level. Is this possible for every application or every workload? Probably not. I mean, there's always going to be workloads where you may not be able to do that quite, or you may have applications that are legacy and they might be doing things that are not friendly to the architecture. But for a lot of the applications that are data intensive, that are memory intensive, memory centric, we are finding really that we're not having to make significant performance trade-offs when we use this technology.
Thanks, Alper. Brian, why don't I know we've done some testing in the labs. You've got some thoughts there. Can't publish the numbers, but how would you have people sort of think about this trade-off with performance and kind of comment on and follow on to Alper's remarks?
Sure. Let me take this moment to mention that persistence is not consistency. And so I suspect that there's going to be a few database vendors out there that are going to come out and say, hey, since we're using persistent memory, we're now a consistent database. And I just like to put in people's mind that ACID has 4 letters, and one is consistency, and the second one is durability for a reason. That's the C and D of ACID. And simply running on top of a durable media like this persistent memory doesn't mean that you don't have holes in your clustering and inconsistency problems or that cause either great unavailability in cap theorem land or create lost data. So Aerospike 4.0, just to give our little plug, came out with strong consistency. We have a Jepsen test to prove it. We have done the work in our clustering and transaction models to make sure that we don't lose data. Now you couple that with the kind of durability story that we have out of persistent memory, and life is looking pretty good. Now specifically you mentioned trade-offs, and what we found was that in the numbers that we have from hardware partners, there almost isn't a trade-off. We've been sitting here inside Aerospike going, geez, why wouldn't every single deployment who could get a hold of persistent memory, why wouldn't they use it? It's going to be cheaper than DRAM, and it's going to, have that faster restart times. And if you saw the numbers, you would go, geez, it's pretty much on par when used with this hybrid NAND solution. This is one of the reasons why we're super excited about it. And what I can say, and did say before, is that we have achieved multi-million transactions per second per server, which is to say the speed that you've come to expect out of Aerospike servers, with persistent memory-based technology, because we did all the work Alper said. Our data structures were already well aligned for DRAM. We did some optimizations about this, that, and the other thing, how to change our allocator patterns here and there, how to do restarts where we sort of carefully check, make sure that everything's correct. It was not a lot of work for us, and so trade-offs. This is why I keep talking to Intel and saying, so when can our customers get a hold of this? Because compared to DRAM, when in these kinds of configurations, we have seen really minimal differences.
Terrific. This is a great question for both of you, and Alper, again, I'll tee you up first, but Brian, I'd love to have your thoughts. The question is what kind of code changes did you guys have to make, and how long did it take for you and Intel to work together to do all of this? And I think that's a wonderful story to share. I think it took a long time and a lot of collaboration. I think people ought to understand how tightly we work together. So Alper, maybe you can share your thoughts on working with Aerospike, and maybe Brian, you can share your thoughts on working with Intel.
Sure. I'm sure Brian will give the details about the specific work the Aerospike team had to do, but I want to touch on the overall ecosystem around persistent memory programming, because really when we talked about this being a totally new tier and a totally new re-architecture of the memory storage hierarchy, it necessitated us to come up with a new programming model that we call the persistent memory programming model. And when we came up with that programming model architecture, we worked through CINIA to make that an industry standard, and it is right now an industry standard. It is not an Intel proprietary technology. It's available to everybody, and having a standard that's out there really allowed multiple OS vendors that are pretty much all the major OSs right now have implemented this and support persistent memory, and the virtualization stacks support that, and the applications support it as well. So that was the first step. So it is an industry standard programming architecture. The second thing that we have done, and Brian touched on this a bit as well, is creating public libraries that really make a lot of the programming around persistent memory significantly faster and easier for the developers. So these that there are specific instruction sets that our CPUs enable to support this, but through our libraries, you just essentially make library calls for whatever functions you may need to take full advantage of persistency and persistent memory technology, and leveraging those libraries and calls, you could essentially just continue your development without necessarily trying to figure out the low hardware level interactions that are required to make it all happen. And in most of our interactions, I think with the Aerospike team have been around that interface. How do we work together with this? How do you incorporate those and take advantage of them? But I'll let Brian to really articulate his perspective on those.
Sure. Thanks. I think that's a great overview of the process. Let me see if I can highlight some of the specifics that we went through. I'm always torn when I'm asked this question because in some sense, I'd like to make it seem easy because we didn't spend a huge boil the ocean amount of time looking at persistent memory and sorting through the APIs. For those of you who are technical out there, want to take a look at the APIs, let me repeat the website. This is, I believe, Intel's sponsored industry standard. That's pmem.io, pmem.io, and you'll see the Persistent Memory Development Kit, PMDK. PMDK, if you look at the long list of the APIs, you can see that there's probably an API that matches your software and what you want to do with it. The one we used at Aerospike, as I mentioned, is the lowest level one, which is libpmem. It's about 4 items down the list. But there's some higher level ones like pmemobj that we did in fact try. They weren't quite suitable for us. So I would kind of like to tell you that, Aerospike did all this huge amount of hard work, and it was really, really hard. But I'm also really excited about the technology and the fact that the guys at Intel and the industry is rallying around things like the SNIA programming model to create industry standards. And you can take a look at exactly how this stuff works. Now, these libraries are primarily C-based. We haven't really looked at what the Java-based systems look like. I think there's some Java code somewhere. And anyone who does Java programming is rightfully a little concerned when they start having to deal with, quote, native code, a la C code. So, part of me would also like to say, well, hey, let your database professionals handle all that stuff. You trust us for making consistency and time trade-offs. You trust us with networking optimizations. You trust us with clusters and scalability. So, of course, my bread is buttered on the side of don't worry your pretty little heads, just add a little more Aerospike into the equation. But if you do have an application that you think could benefit of this, maybe you have your own proprietary tier of databases, do check out pmem.io, talk to your programmers, talk to the fine folks at Intel, perhaps about getting samples, or Google about getting some cloud access.
Terrific. Thanks, Brian. So I want to kind of turn us to wrapping up today's event by thanking Alper, you, for being so generous with your time and your thoughts today. Thank you so much for supporting us. Brian, as always, pleasure to have you share your thoughts. And for everybody who attended, we had a terrific turnout. I was looking at the numbers. People stayed on. That's an indication of the value of the content. I want to forward the slide one more to say where you get information. You can also get that within the console. You can get the slides. You can get access to all the information I'm sharing with you now. Please feel free to download whatever you can. We will follow this up with an email. You will get an access to the recording and the slides. Please share that within your organizations. We want to make sure you have everything you need to be thoughtful about how you move forward with this technology. And again, we're always at Aerospike here to help you. There is a button in the console also to give us some feedback. So if you would, somebody's kindly already done that. Thank you for whoever that was. If anybody else would like to share some feedback, that will be helpful for future sessions, just to let us know how we're doing. So again, thank you, Alper. Thank you, Brian. Thank you, everybody, for attending today. And I'll go ahead and end the presentation and wish you the best for the rest of your day and the rest of your week. Thank you.